Find the minimum base width, B, for the square footing. In this problem, a square footing supports an axial load, Q, and sits 3 feet beneath the surface of a gravelly sand. A number of other variables are also given. Let's begin with the safety factor, 3, which equals the ultimate bearing capacity divided by the allowable bearing capacity. Or more simply, the ultimate bearing capacity is 3 times the allowable bearing capacity. As far as safety goes, we should consider 3 to be the minimum safety factor. Since both of these values are functions of the base width, B, our strategy will be to solve for both bearing capacities in terms of B, and then return to this equation and solve for B directly. Let's begin by solving for the ultimate bearing capacity in terms of B. For a square footing, our ultimate bearing capacity equals 1.2 times the cohesion multiplier plus 0.4 times the effective unit weight times the base width times the wedge weight multiplier plus the overburden stress times the overburden multiplier. The 3 multiplier terms are also called bearing capacity factors, which are all functions of the angle of internal friction, phi. The bearing capacity factors are solved for by first solving N sub q, the overburden multiplier. Phi is plugged into the equation and N sub q equals 37.75. The other 2 bearing capacity factors are solved for by plugging in phi and N sub q. We'll next solve for the cohesion, the effective unit weight, and the overburden stress. Since the soil is a gravelly sand, the cohesion equals 0. Since the groundwater table is not mentioned, the effective unit weight of the soil equals the total unit weight of the soil, which is 120 pounds per cubic feet. Lastly, the overburden stress equals the effective unit weight of the soil times the depth of the footing, which is 120 pounds per cubic feet times 3 feet, or 360 pounds per square feet. If we plug these values into our equation, we find that the ultimate bearing capacity equals 2,703 times B pounds per cubic feet plus 13,590 pounds per square feet. Returning to our initial equation, we have now solved for the ultimate bearing capacity in terms of B. Next, we'll solve for the allowable stress in terms of B. For a square footing, the allowable bearing capacity equals the contribution from the axial stress, the footing weight, and the weight of the soil above the footing. B squared cancels out of the second and third terms, and the equation is simplified. Next, the known values are plugged into the equation, and the allowable stress equals 400,000 pounds divided by the base area plus 420 pounds per square feet. Having solved for the ultimate and allowable bearing capacities in terms of the base width, B, we will now solve directly for B. After plugging in these values and simplifying, we end up with a third-degree polynomial. If we keep in mind that B is in units of feet, we can simplify the equation to read 0 equals 901 times B cubed plus 4,110 times B squared minus 400,000. Solving for the roots of B, the only non-imaginary solution is B equals 6.37 feet. To ensure the safety factor is at least 3, B should be rounded up to 7 feet. Looking back at the possible solutions, the answer is B.